started with presentations, so gather around. So I think that we only have about 5 minutes for each group, so this is going to have to be extra lightning style. I think the main points that you want to get across is what were you trying to do, how far did you get today, and what's left to be done. And it would be great to hear from everyone, regardless of if they actually got much done or if they just have 1 or 2 sentences. I think it's still a great stuff to share. Could I get a volunteer to record, to write down what we've done on the webpage? Or am I going to have to call someone out? It's going to be someone from Delphix, if I'm going to think of it. Nice. So if there's already that list of projects, you can edit that, or and just add like who worked on it, and maybe like a couple words about how far they get. Like it's done, they just need to push, or.
Also, what's your team name?
What is your team name? Okay, I will go first. My team name is Ghetto Send. And what I did was I implemented ZFS send of compressed data, where it gets the data that's already compressed on disk, sends it over the wire, and then when you receive it, it decompresses the data and then writes it again, and then maybe compresses it again. And it basically works. Next things I would need to add like send stream flags. That's not done yet. Add new command line flags to enable this since it's not backwards compatible, obviously. And that's it. So who would like to go next? Mr. Wilson?
I'll do one.
Oh, and would anyone like a beer as we're waiting? We need to leave here at 5:40 in order to get to the dinner on time. So if you want a beer before we go, there's plenty in the fridge.
So I worked on a couple things, but one of them that is in the test phase is to simplify the scrub code. So there's logic today in Scrub to like throttle it back and do all sorts of funny things, but with the right throttle that is added, it's not quite as necessary, and there might actually be some performance benefits of not using that logic. So the idea behind this is that it changes the way that we do scrubs. Now it's based on effectively how many bytes do you want to push down, and if you want to push down like 10 meg, then it sorts them and does them in a pseudo LB order based on that 10 meg. So it's mostly complete, but it needs to be tested.
Cool. Thanks, George. Any next volunteers, or otherwise I'm going to pick on people going through the room. All right. Tony?
Sorry. We also work on a couple of things. So one thing I work on was looking at KMM reap and see if we can be more proactive about reaping some of the caches that have external fragmentation, as well as the other thing that we saw was arc buff header could go to something really big when we have a huge L2 arc. So what I plan to do is basically prevent L2 arc reaping, as well as checking for external fragmentation on the ZIO buff caches, and then see if we can reach that early. I still need to work on that and test it.
And then we also started looking at trying to come up with a way that we can create fragmentation in a very fast fashion on a pool. So we made some changes to ZHack to allow you to pass in, right now it doesn't pass in much of anything, but eventually it'll pass in a histogram distribution, and then we'll walk through all the meta slabs, actually fragmenting them in that fashion. So you'll end up with a pool that has the level of fragmentation that you're looking for, and then you can run tests on top of that. So that code is kind of complete, but we haven't even started to test yet. Yeah. So,
cool.
Questions? No.
Thanks, guys.
Thanks.
Luke? Okay. So for those of you who don't know, the open-zfs.org website and mailing list are hosted by Hybrid Cluster.
Yes.
Thanks to Luke and his company. And
Cool. So we are currently hosting OpenZFS.org, which consists of, at the moment, it's a hybrid cluster deployment, which is our previous platform that was built on top of OpenZFS and FreeBSD. And what I've been working on today is taking the first steps towards moving that to a Docker-based deployment that we can run on top of Flocker, which I showed everyone yesterday. So the website consists of a MediaWiki instance, a MySQL database, a sort of front-end cache called Varnish, and also the Mailman deployment, which consists of a web server and the Mailman components itself and an MTA. So, interestingly enough, I think about 3/4 of those things are stateful components, and so it's a natural fit for Flocker because you need to be able to handle data. And so I'm just working on writing Docker files for each of them, composing them using a Fig application, and then I'm going to deploy them onto a host on EC2. And if we get another big spike in traffic, it'll be easy to move it onto a bigger host or spread those containers out across multiple hosts and so on. So, yep, still a work in progress, but yeah, should get sorted out soon, and hopefully no one's relying on the IP address of OpenZFS.
Cool. Cool. Thanks a lot, Luke. Any volunteers, or am I going to call Andre?
Yeah, so we worked with Justin on some changes that's not new code, the code that's been already developed by SpectraLogic. So I reviewed some of the changes and transformed them to be applicable to Illuma's code base and submitted review requests and opened issues for those changes. One change is really a small bug fix, and another change is performance enhancement, which allows to aggregate, currently synchronous reads and writes are not aggregated, never aggregated, but in some cases it's useful to aggregate them, and the code allows to do that, and it also allows to aggregate synchronous and non-synchronous operations of the same kind of reads or writes.
Yeah, so the aggregation change we saw, at least for an NFS workload from Linux, where they were writing sequentially, but then doing periodic syncs. So a couple times a second or something like that, they would just do a commit, an NFS commit, that we get 98% aggregation hit on that synchronous write stream. So for us, at least in that workflow, it made a pretty huge difference in terms of overall throughput. So together we were able to get 5 things into the queue. So 5 new issues and 5 new review requests. Or actually, I think 1 or 2 of them might have been previous review requests in there, but at least now there are issues and everything. And working on number 6. I was hoping to get a little bit further because we have changes from 2.5 years ago that do the async copyright write fault resolution stuff, and I will get there at some point. Maybe it'll take a couple more events like this, but we'll get there.
Cool. So you guys should also have those reviews in your inbox from developer at OpenZFS.org, and comments appreciated. But I think that your teams are pretty straightforward.
Yeah. And the main point I think of this work was also to get accustomed to Illuma's development tools.
Cool. Thanks a lot, guys. Yeah, I'll go to this table next. Dan, you know?
Yeah. Right. So. Well, what we worked today was get out some case stats, and what our target was to implement some statistics for getting ZIL operations or IOPS or throughput per data set. So this is what we set out to do, and the current point is that, well, we made some progress. We're trying to understand how the case stats are working and how we should allocate the structures and so on.
Right. So the idea and the big upside for those of people who are really trying to understand performance in big complex systems is on a per data set basis. How are you using the ZIL? How are you using throughput? And do those measurements cheaply, and then of course that translates right into the ports to BSD and Linux quite nicely. So more visibility, the more you see, the more you can fix. And also I think it'll fix some of the issues with that right now you would have to either, if you don't have dtrace on the system, it might be really hard to get at some of this information. And we've been kind of spoiled with dtrace on Illumos for a long time, and so we wouldn't think twice about, oh, I need to write dtrace for this. But putting it in case stats makes it much easier to be consistent across districts.
Team Joyant. And I'll mention it, just remind you again that there are prizes for best hackathon project. This is going to be determined by popular vote or something. So keep in mind think about which hackathon project you want to root for the best in show.
Our team name is OS2313 or Fight. David, describe OS2313.
Yeah, so this was the second of the two problems that I talked about yesterday in my talk, which was that we have this race between looks like ZIL close, ZFS rollback, and possibly SPA sync, where there were two failure modes. One was a panic, where one of these times we do this rollback, the system would panic, and the other was a hang, where we would get stuck in a task queue destroy, constantly looping in task queue destroy. It was typical in some function. So that was the problem.
A while back, we had determined that this was a race and had written a descript that we actually do this. I don't know if people do this, but we use EJS a lot. So we write descripts when we find that we can't make progress on a dump. We will at least come up with a descript that captures some hypothesis and will allow us to bifurcate the space a little bit. It's usually an act of frustration, and then deploy that in production. And that way we know if we see it again, we've got a dump. In this case, we did see it again. We did have a dump. And then we promptly forgot about it and did other shit. And meanwhile, OS2313 just continued to nibble at us.
Right, like once a month.
Yeah. So the first task this morning was to locate the dump that had the descript in it. It
took a lot longer than I think.
No, we actually did use another job to locate it. And then from that, we had to catch up to our previous selves. So all three of us have looked at this at various times. And I think it took us all a couple of hours to even get back to my previous self on this, speaking personally. And then we were trying to, I don't know if you, Robert, they would describe kind of where we ended up on it and what we think is happening.
Sure, yes. Basically what we've been trying to understand is why we have, so if you were familiar with the ZIL internals there's basically a synchronous list which ends up in the LWB list, so basically that you are waiting for, but there's also asynchronous operations that can show up. And at various points in time, those asynchronous operations will be transferred to the synchronous operation list as part of doing this. However, because in this case all of our data sets was basically mounted with the default standard synchronous behavior, normal operations don't do this. So what appears to have happened is that you basically have cases where you have things appended to this asynchronous list, therefore the Zilog is actually dirty. So when SPA sync comes around, it will try and clean that up. However, if you're tearing down the ZFS VFST, because it's not one of the synchronous operations, when you go and do a wait on all of the synchronous, when you basically do your SPA sync wait, you're not going to actually be able to, you're going to wait for something, which happens to not be the thing you care about, go around. In the panic case, we've actually just continued going on through ZFS VFS teardown. So we destroy the task QT, so therefore when we try to do a task queue dispatch to null, blow up. In the race, the assumption is basically that task queue dispatch, there's a task queue destroy so there's no entries in it. And so it's trying to add an entry, remove an entry. Because we try to add one token entry to kind of clean up its internal state. And because there's another entry there, there's always something there, and basically it's in an infinite loop.
So it's a ZIL close SPA sync race that is induced by a Zilog that is dirty, that does not actually have an asynchronous ITXs on it.
And our hypothesis here, so the whole point is that ZIL close has to make sure that anything that's dirty in the ZIL is going to be written out before the ZIL is closed, right? That's what we're trying to do. And our hypothesis is that this code path is checking that all synchronous stuff has been written out, but is not covering the case where asynchronous operations that are queued up in the ZIL are there.
And we did verify that that's a valid state for a side log to be in.
Yeah.
So we did a user panic, we got a side log that's in this state where it is where it does not have any ITX, but it is dirty. So we know that's possible.
Yeah, basically just panic the system right after ZFS write returns, so therefore you know you've basically done this asynchronous write that will be synced down. And you have the asynchronous ITX entry,
Right.
but the actual synchronous entries are all basically 0.
And we have a 5-line fix that we believe will fix the problem. Or if it doesn't fix the problem, then we're being punished for original
To be
sins.
fair, 2 of those lines are white space, right?
Actually, I think some of those lines are white space, just to gussy it up a little bit. We felt that it was a little bit inadequate having a hackathon that resulted in 5 lines of code that we haven't yet compiled.
And probably can't test, because there's definitely something else here.
Right.
That the window is super narrow, because if we do the rollback right after that test, we can't reproduce this problem. And we knew that anyway.
But in a moment of giddy late afternoon hackathon optimism, Dave believed that he was somehow going to like induce this on a single rollback, which of course there's just no, and it's been running in a for loop ever since. Like, there's no way. We know this because we do believe that the descript actually moved. The descript made it much less likely to hit this, and we know that pushed the window out in the order of like 100 microseconds. So we know that this is a super tight window.
And
We've only seen it a
for
small handful
example,
of
like
times.
the difference between the infinite loop case and the panic case is maybe a change in maybe a 40 instruction window. So it's like, it's just kind of.
It's super tight. We've only seen it a handful of times. The question is Dave ultimately going to be dissatisfied?
It's going to panic when I go back over there.
It's
I know it's in
You
this.
have to do this to yourself. I can't watch you do this
Can
to
you add a
yourself.
chill to like use?
Well, this is what you're right. This is what we would. Well, I think the only way we would be able to do this.
Where would you put it in Spasync entry or something?
Like, or like DSL pool sim done before it
Okay.
calls like the Zope lead or something.
Yeah, that's good.
Anyway, that's what we
We'll
got
do
to
that.
We'll do that.
Okay, next step, do what George says.
Yeah, exactly.
All your problems will be solved.
Right, and I think we will probably integrate the fix in our quad and deploy it to production. So.
Cool. I see Chris and Paul over there eager to demo their code on the other side of the room.
Yes, we spent our day making a live demo.
Yeah.
/ fixing bugs.
All right, so we have here a system set up for the pool called test 2.
Don't ask about test 1.
Don't ask me about test 1. So there's some I/O running on this pool, writing a bunch of like bad.
Writing to a file system called IO waste.
Yeah. I forgot to do one thing. All right, so we're going to create 500 file systems, or 500 data sets. So we're going to do ptime./slow create. And so what this does is in a for loop, do ZFS create. And that's it, creating file systems. While we're waiting for that, we're going to go over here. And we're going to do sudo ptime ZFS channel test2 demo1.loop. And this is also going to create 500 file systems. And we're done. We're going to do ZFS list -r test2 pipe-ls. Or that was test 1. What happened to test 1? It's got other stuff in it. So as you can see, there's, in fact, lots and lots of file systems, and there's only a few slow file systems. So that's step 1. Now we're going to do step 2. Let's say that this was like a bunch of data that, was either internal or customer data, and you didn't feel like keeping track of which was which very well. The only thing you did was you set a property on it. So we're going to do sudo ZFS set customer ID equals joint.
I think they want to see the Lua script too, but we'll get to that.
Oh, yeah. test2/fast/fs127. Let's say there's another one for Delphix. And let's say there's one for, I don't know, OmniTI.
Up there, there should be more back.
All right, so now let's say what we want to do is we want to snapshot everything that is a customer ID set and destroy everything else. Normally, you know, you'd have to be like, oh, okay, I'm gonna list all these, grep through with the ones for customer ID set, and then like do all the stuff.
Show
But
us the
there's-
source.
Yeah, there's an easier way to do it. So demo2.lua, for each FS in the file system, if it has a customer ID, then snapshot it, otherwise destroy it. Then return the list of ones that we snapshotted. So, so now we're going to run it again. And we now see that there were these 3 file systems with this property set, and it destroyed all 500 in 2 seconds. We go back to the other one. This one took almost 2 minutes to complete just the creation. Destroying is a lot slower. Like, much slower. And Chris is going to talk about the... Are you going to talk about the IOPTL that you changed?
Oh, yes. It's really boring to demo, but I changed the snapshot IOPTL to be backed. I basically deleted all the C code as soon as you get into the part that's called ZFS IOPTL snapshot. I deleted that and replaced it with like a 30-line script that doesn't quite get every edge case, but the edge cases it doesn't get are things like pools that don't support taking snapshots due to their file system version. So we'll get there eventually. But yeah, so it behaves exactly the same. The channel program itself takes as input the same NVList format that the old IOPTL took, and outputs the same NVList format that the old IOPTL returned. So, and the code it lets us delete a bunch of code.
So when are you pushing? When's the review going up?
Yeah. When's the review going out? We can put out a review for stuff that already exists now and people can look at it. It's not ready, probably won't be ready to push for a couple months just because when we'll have time to work on it. But the main thing left to do is to write tons and tons of tests and then fix all the bugs we find.
Yeah.
Did you decide that you're going to allow people to submit their own LUID?
Yeah, so the ZFS channel command should be part of it. Should be part of it, although it's only going to let you run it if you're root.
That's the source for demo 1, by the way. It's about as simple as it gets. Yeah. The other things we did, we also fixed some, it used to be that you could only return very specific NV lists, and you couldn't list clones or create them, and we also fixed all of those today.
Yeah. Most things now have functions in the Lua script that you can run.
Yep.
Have you considered like a dry run option or something like that?
There is a dry run-ish option. So the problem you can't dry run an entire script because it's pointless. Because unless you're making the changes, if you do 2 dependent operations, unless you're actually making the changes, you know your script is going to just behave differently in dry run versus not dry run. Now you can do what Paul's about to do. So here, creating all the file systems isn't dependent. None of those operations are dependent on each other. So instead of there's like 2 versions of every sync func that you can run. There's a version that actually does the operation and a version that returns the same error / success that would be returned if you ran it in the current state. But if you do multiple checks in a row and the later ones depend on the previous ones, you're not going to get the same results if you ran those as synced up funcs. So like the snapshot IOPTL, when I replaced that, I did do it by iterating. Oh no, I did some of it by iterating over and like pre-checking that some things were going to work. But then things like snapshot limits have to be enforced, based on how many snapshots you actually created. So the way that the new Lua script does it is a bit different because it just goes and starts creating everything, and if it eventually hits the limit, it just goes back and destroys everything that it created, and nobody ever sees the intermediate state because it was all done within one TXG.
Yeah, it'd be nice if there was some kind of like generic back.
It would be nice, right, Matt?
Yeah, next hackathon, right?
Yeah, Matt doesn't think it's possible. It'd be really hard to make that generic. Because right now we're just calling the same sync funcs that exist, and they just, that's most of ZFS. They go out and they update everything. They just change whatever state they want. So you have to do some sort of staging of the changes that doesn't get committed until the script succeeds.
For some reason, this is actually creating the file system.
Are you sure the file systems don't already exist?
Right, yeah.
Yeah.
That's a dry run.
It's all right.
It's a moist run.
You don't need to live debug it.
But anyway,
Cool. Channel programs. Thanks, guys.
yep.
That's right.
Prakash and Alice.
A moment to screen
Okay, sure. I'm going to go around the people standing over here.
Really nothing special. The very early proprietary phases to take the issues right as suggested smartly predictive data output into the Z2 status command. And that's the preliminary. And the other thing is waiting for a K to ZFS about 192 TB with fresh TBs from a brand new cluster and scripting that to that it can go out quickly once the OK comes.
Dan?
No, sure. Do I need a team name? Team
Yes.
Newbie?
Yes.
Yeah. Team Newbie. People who do ZFS, who do OpenZFS work on non-Illumos platforms, since Illumos is still the upstream of OpenZFS, they need to build on Illumos. And 0 to nightly takes an hour with good hardware and more without. So Delphix had a nice script that was quick and dirty and would build just the OpenZFS bits. Still some code, but it can be measured in minutes instead of an hour. So I ported it into user source tools for Illumos. Had some people try it, wrote a man page for it. It is now up for public review. If you've read your mail, you'll see it on the Illumos list, the ZFS for Illumos list, and the OpenZFS list. And I had some of the people try it. Was it terrible? Was it okay? It seemed to work okay. I got a FreeBSD thumbs up. And it works on both OpenIndiana and OmniOS with stock Illumos Gate, because building all of Illumos Gate on anything other than OpenIndiana is still painful. I've got diffs under review. You Illumos people in the audience, please review them. But just the ZFS bits work pretty well. I suspect they work on SmartOS 2. We had some bad luck getting them on there, but that's probably bad luck and nothing more. So yeah, it's a good litmus test for somebody's changes before they go upstream. And if you can get past that, then you can engage in the Illumos community knowing that, hey, ZMake worked.
Thanks, Dan.
Thank you, Dan.
Other folks standing over here? Tell us what you worked on.
I didn't work on much. I was an Illumos newbie.
So what did you accomplish? Did you build ZFS on Illumos?
I did not. I got distracted from that. But I did pay attention. Okay. And I learned a lot about Illumos, which is very good, and how it works. I got distracted by a minor bug fix that got brought up. So it turns out that if you have a suspended pool and you're trying to export it, you will deadlock your system, the current code.
Yes.
Because the pool check function is not implemented. So, or not set, it hangs. So if you, and then if you run subsequently, so the deal is, if you have suspended pool and you run the pool export, it will run through, it'll run the handler on the kernel side, at which point it will take the namespace lock, and then it will block, waiting on I/O to the pool.
Filed a bug for this like years ago.
Which is really unfortunate, because any other command, like say people clear, will attempt to acquire the namespace lock before they can clear it and unsuspend the pool. So you end up in this very unfortunate state. So I made the even better one-line change to actually put the right handler in place, so you get an error now from pool export if you try and export a suspended pool.
And now hopefully you have the skills to be able to upstream that to Illumos.
I do, actually. And so I'm told that I can open reviews.
Yes, you are encouraged to.
I have reviews for you. So.
Cool. Alex, are you guys ready back there?
Yeah, more time to buy the cooler the demo would be.
Okay, we'll give you some more time. There's some more people standing over here. Richard, or anyone else standing over here?
I got some more time to refresh the supply when you.
Okay, I'll give you a bye. How about you guys?
I'm a noob, and now I can compile ZFS.
All right, down Illumos, great. Other news? I see someone. You?
Oh, yeah. Yeah, so we were trying to keep account of the number of objects under a certain user ID or group ID, in addition to the number of bytes, which is currently accounted already. So it's very easy to do it incrementally, but the biggest problem is to when you upgrade a pool, you have to go through every object in the data set to count the stuff. And I looked at the old code that does the accounting for user and for bytes for issuer and group. I believe, well, if I understood it correctly, what it does is to write a bit into every single denote in the data set to mark that as accounted or not. But we were trying to avoid doing that because that's going to be quite expensive for a big data set. Also, I don't think you can easily do it when there's ongoing change on data set. So we looked at a couple of ways to do it and decided that it was easiest. Well, easiest for my skill level to implement is to just take a snapshot of the data set, and at that point divide the job into two parts. One part is to do the regular incremental accounting as a TXT syncing time, which basically means you can end up with negative counters because you haven't counted the original the snapshot yet. And on the other hand, to iterate over the objects in the data set in the snapshot, which is read-only, so and update the counters accordingly. And the nice thing about that is we could limit the amount of work per TXT, and also there could be ongoing change to which is accounted by the incremental counting our updates in the TXT sync. So we could do something like a red throttle to look at the amount of work which is currently pending and decide how much we want to go through in each. Yeah. So yeah, basically that's it. And when everything is done, store the snapshot. Cool. So yeah, that's it. We haven't done coding yet. But yeah.
We have a wonderful design document that
Yeah,
easily been translated.
Yeah, I was trying to get some coding done because, well, basically that's my paper. So, but we just wasted some time in some to explore some other possible solutions. Also, Brian suggested to instead of reusing the existing ZAP objects, we should create 2 new ZAP objects to do that. So that if we want to disable the feature, we can just simply remove the ZAP object instead of going through the existing ZAP objects to find out which entries are belong to the object accounting or not. Okay. So that's it. Hopefully we can have a patch for ZFS on Linux.
Plus, I have some zpool subcommands and man pages.
Oh, cool.
Cool.
That's great.
That's it.
All right. Thanks, guys. I see. What is your name again?
Me?
Yes.
Yeah, Steve.
Steve. Would you like to tell us about what you worked on?
Coming up there seems like a bit much.
All right. Well, you can stay where you are.
All right. So I started off the morning learning a lot about Illumos. I didn't get all the way through the build like most newbies, but it was really great to learn something. Then I went in the afternoon on to looking at what Docker, what ZFS would need to provide Docker. So going through the class for, they call it the graph driver, and seeing what ZFS calls need to be made, writing that up in a pretty reasonable, what I thought was reasonable setting. Then I learned a bunch about why the current pull request doesn't work, and made some progress on that.
Did you comment on the current pull request, or how do you?
No, yeah, I've got it just in the bin file, so I got to email it around or something.
Yeah, or just
Yeah,
maybe put it in the pull request, or that'd be great. Yeah, I would love to read it.
Yeah, because there's a bunch of people talking about what the API would need to give us in order for Docker to be able to use it, so I guess I got that.
Cool, that'd be great.
All right, I'm going to do one more table, and then the people that I skipped are going to have to go. So, can you go ahead?
So what I worked on was actually picking up something I started about a year ago. So basically, there's a number of ways the space maps can get out of sync with the actual state of what's actually on the actual response that's been allocated. And it's written out as the free and allocated lists. been at least looks like multiple bugs that can cause, probably in a few that haven't been fixed, that can cause space-time corruption one way or another. And Joanne had a sort of workaround in which because it can prevent you from importing the pool. And so the workaround covers the case where the space map is internally inconsistent, where they're overlapping ranges and stuff like that, and sort of trying to get around that issue. And if the polls read only, you're all good. The allocators don't really do anything else. But for the general problem, like the space map itself is all that information is already extractable if you just traverse the entire tree. So ZDB kind of does that to try to look for leaks. And we can also just do that ourselves or more do it exactly, you use the ZDB traversal and reconstruct. So what ZDB does is it loads the space map as an alloc map, and then loads the real and tries to do a traversal. And then if there's anything left over, that's leaked. But if we want to just build a new alloc map by walking the tree like that, and then hopefully we can write that back out, and then everything will be happy. So what I was trying to do was basically getting that functionality into ZHack initially anyway, and I had George look at it for a little bit now, and it looked like that would have been the same approach. It turned out that I ended up re-implementing, so ZHack got larger than like more than twice as large as it currently is. Before I realized that I probably should just try to get ZDB to open the pull in write mode. So I spent I guess ran out of time before I got that working. And there's also some other changes I need to make because when I did the original changes to make the new space map, this was before the stuff got turned into registry and whatnot. But I think that's a minor. So hopefully I will have something working pretty soon. It seems to be saying. Yeah.
That's great.
All right.
Okay. All right. Well, I'll get you after this table out.
So you essentially written the first version of ZFS FSC.
Yeah, I didn't want to call it that. The ZDB now knows sort of how to write to the full.
Yeah. So I'm Jamar, and so we Team Hash. My goal was to actually get originally to get SHA 512/256, but after some discussion with him,
I've been sitting on that for about a year now, and essentially we decided to anger the gods of mailing lists, and we are going to be trying to propose a new hash once again, and it's probably going to be Lake 2, which, if all goes well, people will accept without too much grumbling. It's secure, it's fast, and
much faster, like to the tune of like 3 times faster.
Does it have any intellectual property crap attached to it?
There's a SHA-3 finalist.
Oh, that's right.
These.
Okay, good, thank you. Yeah, I'd be a SHA-3 finalist, okay.
Yeah.
And yeah, so the initial version that we were working on is probably not going to be like using those crazy SSC and ADX optimizations. We are basically trying to get the foot in the door, getting everybody to accept the thing, and then we are going to be spending our time probably optimizing the hell out of it.
So yeah, basically I took his code that he had done on various other hashes like SHA 512/256 and some other stuff, got them into a Git repository, and actually used Dan's zmake.sh script for the install on the OS and actually build and get compiler errors because of the changes that I did weren't complete. So
and I also then did so that's mostly John did.
Yeah.
I was kind of just consulting for that.
Yeah.
My work was kind of resurrecting my SCSI on map patch from a while back and getting it to finally not panic on me right away on boot. And I did get there. Unfortunately, I did spend some time wallowing around in the sd.c cesspool, writing a new SCSI unmap command implementation, but so far I don't have any real hardware to test it on, so that's going to be a doozy for later. But yeah, right now it boots, runs VDBench fine, I suppose, with Matt's and some of the Delphix guys' help. And yeah, so we're going to be seeing how far we can take that. There's going to be a lot of optimization that needs to be done and determining how far we can take that and whether it makes sense. Yeah.
Great, thanks guys.
These guys are really
Do you have questions? No.
Okay.
Pablo, do you want to?
Yeah, so
You're next.
You're next?
You're next.
After. Right, so I was part of the team working on data. So basically I was working on data corruption when we lose the power of the backend disks of our pool. And then we resume the pool after plugging back the disks. So what happens basically in ZFS is that whenever your pool was suspended, when you resume it, you resend all the ZIOs that failed. The problem with that is that some of the ZIOs who actually returned success, they were actually not successful because we didn't send a flush command. We only send a flush command when we finish the whole TXG sync. So basically what I was working on is trying to make a batched flush for all the ZIOs which are sent to VDF. So it's not a ZIO by ZIO flush, but there is a bunch of ZIOs which are being flushed all together. So it can be done like every 100, 200, 300 milliseconds. It's a configurable sort of parameter. And yeah, so basically I did a code outline for that, and I started doing the code, but there's still a couple of days of work to do. Should be good soon. So I was helped by George to implement that.
Great. Okay, Alex.
All right.
And Prakash.
Demo time. So, Prakash saw this cool video a while back on statistics. So the idea here is this is a graph showing on the x-axis time, and on the y-axis is some statistic values, and we have a stream of points. And as you can see from the stream of points, there's this point in time where all of a sudden, right around here, where all of a sudden it jumps to a different, like the average jumps to a different value. And right around here it jumps to a different value. And you can do stuff like compute the cumulative total average of all the points you've ever seen. But then you are very slow to recognize these effects. And so the talk is about how they use this crazy research paper to, what they generally do is they keep a sample of the points they've seen so far, and they are more likely to throw away points that are farther away than points that are more recent. And as a consequence, when something like this happens, you notice almost immediately in your sample. So, our plan was to add this to ZFS. In particular, we wanted to walk up to a pool where we hadn't been running dtrace and didn't know anything about it, and say, well, this disk seems slow. Has that always been the case? Well, like, you know, how long has it been the case? What are the things we should be paying attention to? And so we created an infrastructure called ASTAT, for Alex Stat, aggregation stats, or something like that, ASTATs. And so the way it generally works is we have an ASTAT, we can print, and we get a histogram. And this histogram is generated at the time of the MDB command from the sample. But the cool thing, and hopefully this will cooperate with me, is we provided a parameter for how recent of points it allows, or it prefers. And so, if this cooperates with me, oh, this has the old points. Yeah. Oh, well. So, this is actually generated using the sampling method out of the paper, where it prefers points in the last 5 minutes rather than points of all time. Cool.
So what did it sample exactly? The times it took to
Oh, that's a great question. What is this data I'm actually showing you? So this you know, for lack of something better, the simplest possible thing we could time, we just time SPA sync times.
Okay.
But our vision is to have this for all sorts of things, like ZIO latencies, or ARC read latencies, or ZIO allocation sizes.
Lab allocations.
Anything we want.
How do I interpret these numbers?
So this
These
is,
are nanoseconds.
these are nanoseconds, and so
2 to the power.
this is 2 to the 13 nanoseconds. This is 2 to the 27 nanoseconds.
That's the number of spacings that happened within that time.
And then there were 48 nine.
But only in the last 5 minutes.
Well, it's not only the last 5 minutes. It's probabilistically the last 5 minutes.
No, I think this is overall time. This one.
This one is actually, well, I mean, this truncates to 1,000. So
what's next, guys?
what's next?
Yeah.
Make it
When are
stop.
you gonna push this?
Well, when we first, there's a panic we have to fix.
Right.
And how much larger is the spot T now?
That's dynamically allocated.
So, times the question.
Don't worry about it.
I think about it. So cool. I think.
Do you wanna?
Sure.
Go ahead, Richard.
So, let me just get. Oh, there's no water left. Oh. So I was also part of Team Unity, and I used to think that, okay, so the way that I started out with Gentoo Linux and also did a brief stint with Gentoo FreeBSD, and with those, it's very easy to make changes to how you do installations. If you want to make things subtly different or extremely different from how someone else installed it, you can do that. And when I tried to do things with a room nodes initially, that didn't work out quite so well. And after working with Dan, it's occurred to me, finally, that it's not that there's some thing that I'm missing. It's just that if you do not have everything done exactly like someone else has done it, or exactly like everyone else has done it, it simply won't work. The build system is just not that flexible. So I tried a few ways before Raphael actually managed to kidnap me away from Team Noob and told me about his interest in being able to boot off multiple VDEV, well, have root pools with multiple top-level VDEVs. And it turns out that this is actually something that FreeBSD supported for a while, but that bootloader is only applicable to FreeBSD. And I've done quite a bit of miscellaneous tracking, well, I've done quite a bit of tracking down of bugs in Gentoo's Grub2 package. So I know that Grub2 actually is theoretically capable of booting off multiple VDEVs. In fact, I not only know it, but I tested in the past with a Fuse file system drive that basically uses the Grub2 file system code. And I actually repeated that earlier today and verified that it does indeed work in principle. So I threw together a script to automate setting up Gentoo on a multiple VDEV pool. Now I actually just got the result from that script. Well, Grub2 is theoretically capable of doing it. The Grub2 make config file, or make config utility that's supposed to generate the config file for booting Grub2 is not able to actually generate a valid configuration. So in principle, if we were to do that by hand, or just first do it by hand to verify that it will work, and I believe it will, we should be able to boot multiple VDEVs with, well, we could boot a root pool that has multiple VDEVs using Grub2. And quite frankly, all that really is blocking that is fixing the config file and then the config file generator, and then it will just work. So that is one of the things that I did after Raphael kidnapped me.
Yeah, so afterwards we started work on the mmap from ZFS on Linux, where we're trying to avoid copying the ARC buffer into the page cache. So we started an implementation. There's a lot of work to do. We have to get to know better the memory management subsystem from Linux interface to, for example, to interact with the ARC buffers and the page cache structures. So there is a lot of work to do. We have just started.
So I guess that's about it.
I really wanted to demo the first Linux boot of multiple VMs for you guys, but unfortunately the glove config file needs to be written out by hand and I haven't had a chance to do that. In fact, it was like 15 seconds before Matt called my name. It had finished and I was able to see, oh, this failed because of Grub2 make config. Everything else worked. The file system driver has support, Grub2 probe has support. It's just that config file generation. Anyway, so that's all I have to say for now. Thanks.
Thanks. Cool.
That?
Yep.
So what I worked on today was a feature we called large dnode, and what that means is you can specify a alternate larger size for dnode, larger than the default 512 bytes. So why would anybody want that feature? The key point is that if your application stores a lot of data in the system attribute area, currently that means that you'll have a spill block probably for every dnode to store that data. So if you imagine that you read a dnode block and it has 32 dnodes in that dnode block, and if you want to read all your system attribute data, that means you have to do 32 additional IOs to fetch all those spill blocks. For applications that make heavy use of standard attributes on Linux, that might include SC Linux or Lustre, which I work on back in my job. That has a heavy penalty. So we're really interested in large dnodes because we could double the size of the dnode, and that would allow us to pack all of the extended attribute data into the dnode blocks. And so potentially 33 IOs becomes 2 IOs, right? Because you read, currently you read the dnode block and then the 32 spill blocks. If you double the size, you can read 2 dnode blocks that each contain 16 dnodes, and so that's a pretty dramatic reduction in IO in the ideal case. So that's why we're really interested in it. So where I started today, I was building on a prototype. Prakash had worked on it earlier, and I've been trying to extend it. And we basically do, it currently does the naive thing where it lets you specify a property that specifies the new size. And I said, okay, and we'll just set the bonus length of the dnode based on the current property value, and we'll squirrel away our bonus buffer in that space and see what breaks. And lo and behold, lots of stuff breaks because I don't know enough about ZFS internals to find all the sharp edges and assumptions that are spread throughout the code. So if I did know more, I'd be more systematic about it, and I would know all the places that I need to find and modify to make it work right out of the box. But when I started today, where I was at was that if I ran zpool scrub, I would hit a panic, and if I ran ZDB on the object where I had saved the extra data, ZDB would segfault. So I was able to fix both those things today. So that gives me hope that this is not a totally crazy thing to do, and I can work through all the bugs that are remaining. Prakash?
Do you think that'd be a good use case for storing smaller than 4K files in a 4K HShift file system?
Oh, you mean like embedded data in the
Yeah.
dnode? Yeah, that idea did occur to me. So if we have this extra space in the dnode, that seems like a reasonable thing to want to do with it.
Yeah. Thanks. Is there anyone left except for John? Did you guys have any more projects? Okay, John.
So originally, Don and I started out just adding some tests to the test runner, some tests that he had been using at Corate for the ZIL. And when we were done with that, Don split off to work with Brian. And so after that, I added a subcommand to zpool that lists disks that aren't yet being used by ZFS. So you can do something like zpool create tool name backtick zpool available, and it'll just use the rest of your disks. It works, but it's probably needs a lot more testing.
So stay up here for a second. So we have 3 awards to give out here for 3 different things. The second one is going to be best hackathon project. So think about which team you want to vote for best hackathon project. The first award is the Matt Aaron's handshake of appreciation for writing up all of the hackathon ideas that you guys just said. I've seen John just typing away furiously for the past hour. So we have him to thank for taking notes here and bringing your ideas, all the ideas that you guys worked on today, to a wider audience, which we'll post on the mailing list and website later this week. So thanks, John. So the second award that we have is donated by our sponsor, Nexenta. It is up to 3 wireless sound systems for your phone or other things. I think it can also charge your phone. It can probably like turn into a robot or something. I think it has like 7 functions in one. So I think the way we should do this is point to or yell out the name of the team that you think should be awarded the prize Best in Show.
Channel programs.
Yeah.
All right, channel programs, guys. Any contenders for better than channel programs?
Stats.
Stats. Should we have a runoff voting? All right, channel programs. Everybody clap if you want them to win. Stats. Clap your Here's what we're going to do. You each have 2 people. So channel programs guys are each going to get 1, and then you guys are going to have to fight to the death. And the last prize that we have is for someone who we could not have made this event without. And she's sitting over here. Can you come up, please, Anastasia? OpenZFS brand Nut House wine. For organizing everything and making this event possible. Without you, we could never have done this. You made all the food happen and the event happen. Everybody show up here and got all the sponsors so that we could do all this. So thanks so much.
Thank you.
Extra thanks for Roman because it took us a really long time to figure out how to webcast this, and he spent a lot of time helping on it too.
Thanks a lot, Roman.
Thanks to make Wi-Fi work as well.
So our dinner reservation is 30 minutes from now. We need to leave here in about 15 minutes to walk over to the dinner. So you have 15 minutes to put any finishing touches on your hackathon projects, and then we will leave at 5:45 sharp. Thanks, everyone.